Good morning to one and all. I am G Vamshi from Tripoli branch. Today's my topic was about boosting fundamental output voltage in data modulator inverters. Contents of boosting fundamental output voltage in data modulator inverters are introduction, author affiliation, abstract, delta modulator with PI controller, optimal DEM driver circuit, results, conclusion, and reference. First introduction. This letter presents an improved delta modulator with proportional integral controller that generates a switching pattern that can handle inverter switching requirements with minimum complexity. The new delta modulator also optimizes the slope of the feedback signal, window width and magnitude of delta modulator DCM reference signal. It has been found that proper selection of these parameters play a vital role in the design of voltage source inverters with special application of adjustable speed drives. Author affiliation School of Tripoli, Nanyang Technology University, Singapore. Abstract. This letter presents an improved delta modulator with a proportional integral controller that generates a switching pattern that can handle inverter switching requirements with minimum complexity. The new delta modulator also optimizes the slope of the feedback signal, window width and magnitude of delta modulator DMN reference signal. It has been found that proper selection of these parameters plays vital role in design of voltage source inverters with special applications in adjustable speed drives. Delta modulator with PI controller. A proportional integral PI controller is integrated into the DM by introducing an additional feedback resistor RF. Unlike in simple DM circuit, an additional gain factor of open open bracket of slash into star close bracket RRV 33 F is introduced. In the proposed circuit, RF is proportional controller of PI controller as the gain of the overall circuit can be controlled through adjusting the value RF. The circuit of integrator XA2 constitutes the integral components of the controller. The proportional and integral controller are combined together to form the PI controller. At node 1 of DM output voltage without PI controller can be obtained as V output is equal to minus R3 C1 though V3 by though T. Equation 1 represents. With PI controller of equation 1 changes to V out by R3 plus C1 though V3 by though T equal to V3 by RF equal to 0. Equation 2. After simplification, the delta modulation with PI controller DM PI output voltage V out is obtained as V out equal to minus R3 C1 into dou V3 by dou T minus V3 by RF into V3. V output equal to minus R3 C1 dou VT by dou T minus V3 by RF V3. It found that the order to obtain maximum fundamental voltage source into inverters VSI output voltage, one has to select an optimal value of feedback resistor RF. Fourier analysis of DM output voltage V1 in the figure 1 was performed. The three different values of the feedback resistor RF. Figure 2 shows harmonic spectra of DM PI output voltages with a PI controller for four different frequencies of DM output signals VR. The DM fundamental output voltages are normalized with respect to same for a reference signal VR and having a frequency of 112.58 Hz. The investigation is carried out for four selected reference signals and frequencies from 50 Hz to 112.5 Hz. Other important parameters such as Window width, slope m and amplitude of reference modulating signals VR are kept constant at 1V, 2000 V by S and 55V respectively. Below represents the harmonic spectra of conventional without PI controller. Delta modulator output voltage for different values of VR. Comparing with this figure 2, this is evident that implementation of PI controller has boosted the fundamental voltage component from about 0.53 pu in ordinary DM to about 0.68 pu in the DM PI for a VR of 50 Hz frequency. In table 1 about voltage boost produced by different values of RF. RF normalized fundamental value at FM equal to 58 and percentage at low voltage boost. First one RF equal to 0.564 and low voltage boost is 0. 68K equal 68K and 0.676 is and 20. 100K resistance and FM equal to 0.6146 and percentage is 9. 130K resistance and FM equal to 0.6 and percentage 6. So voltage boosting is calculated from selected values of RF based on fundamental voltage with the PI controller only. The results are tabulated in table 1. From the table, one can conclude that the PI controller provides a voltage boost of the fundamental VSI output voltage V1, Vi. This voltage boost is very important feature for induction motor drives, especially at low speed ranges, as the voltage boost of fundamental components helps to compensate the poor motor torque pulsation usually present at low motor speed operation. Optimal DM driver circuit based on results utilizing different parameters: window width, slope m and amplitude of reference modulating signal VR of DM circuit finalized. Optimal DM PI is assembled for a one phase driver. Second point, the optimal DEM PI is able to significantly boost up the fundamental inverter output voltage with minimum low order harmonics and also maintain much needed constant V by F ratio. And figure 4 represents about variation of fundamental voltage versus modulating frequency for DM with and without PI controllers. And figure 5 was about inverter output waveform captured from a oscilloscope. B inverter output waves from harmonic spectrum FFT captured from oscilloscope. The setting small window width of 0.3 volts and slope m to be 4000 V by S. It is found that magnitudes of low order harmonics decreased and dominant harmonics are shifted to the higher frequency domain. And third, it is found that amplitude of VR increases and magnitude of hard harmonics of VA increases. Hence, VR is fixed at 4.5 V. The setting of large slope value at 4000 volts second results at low functional output voltage of VI. Therefore, PI controller of RF 68K ohms is used, which is able to provide 20% voltage boost to fundamental component. Figure 4 shows the variation of fundamental output voltage obtained from DM with and without controller. From results, one can observe that the proposed DM model is able to provide the constant rules for edge control for preset frequency range of operation. Unlike in other PWM modulation techniques, which requires a use of filters for harmonic attenuation, that proposed DM is able to achieve the low order harmonic without use of filters. The magnitude of all the harmonics of VI is kept within 5% of fundamental voltage even up to 21st harmonic. The proposed optimal DM PA parameter selector as follows. Window width is 0.2 and slope is 4000 VBS. FM frequency is 50 Hz. AM VR magnitude is 4.5 volts and RF is 68 k ohms. The results as experimental optimal DM circuit is built and it is applied to gate driver circuit single phase IGBT inverter. The inverter output voltage is shown in figure 5 and figure B shows harmonic spectrum. The spectrum shows the absence of lower frequency harmonic and high fundamental DM output voltage. The first significant harmonic is the 15th, which is expected to be easily filtered out by motor inductance and hence additional filtering will not be necessary. Conclusion: the proposal by DM with PI controller DMPA and with a proper time constant, mysterious band and amplitude of input reference signal can result in optimal VSI gating signals as required in adjustable speed drives. The selected gating signal generator is capable of boosting the VSA fundamental output voltage by 20%. Inherent constant V by F characteristics results in absence of feedback circuit, simple power off circuit. Reference: PD geogas delta modulation techniques is statistic PW inverters IEEE trans and applicant 1994 March April 1981. MA Rahman JE MA Chaudhary performance analysis delta modulator PMW inverter IE trans power electron volts PE2 number 3 PB is 20 227 into 233 July 1987. MA Rahman JE Kyahi and MA Chaudhary harmonic minimization in delta modulation inverters using Turner filters IE PESC volume 1 PP 22 to 28 April 1988. And thank you. This PPT made by G Vamshi.